Hello everyone, welcome to DataChaps. Today we are going to do a crash course on Pandas. So that's the agenda we have for us now. So we are going to see how to import Pandas, load the data from various sources like CSV, JSON, Excel, and from dictionary, and how we can visualize the data in Pandas data frame, the statistics, descriptive statistics we can see from Pandas data frame, properties and shape, filtering, data cleaning, manipulation, data types, indexing, sorting and grouping, and graphs. So that is the agenda. Without wasting any more time, let's jump into the crash course. So what is Pandas basically? As we can see here, Pandas is a Python library used for working with data sets. It has so many functions to analyze, clean, and manipulate data. So we can say that Pandas is an essential library for data professionals, anyone who is working with data. And the way we import Pandas is simply import Pandas as PD and loading data from various sources. Basically, we load data into Pandas data frame. So then the question arises, what is a data frame? A data frame is a data structure constructed with rows and columns. It is more similar to a database or an Excel spreadsheet. So it's basically a two-dimensional table of rows and columns. And the way we read data into from CSV file is simply say data frame variable and pd.read CSV. This pandas actually provide so many functions like reading CSV, read JSON, read Excel, and everything. We'll get to that once we uh, uh, get to that point. We'll learn more about that one. And when I do read CSV, I have to specify the path of this one. So in my case, the path is in datasets, and I'm using a car price dataset which I downloaded from Kaggle. When I run this cell, okay, I have to import pandas first. Okay, okay. When I run the dataset, so that's the dataset I have, the brand model, all the columns, and then the price. And then how do we read from JSON file? So I don't have a JSON file. As we can see here, I only have the CSV file. So what I'm going to do now is the CSV file which I've read. Pandas also provides some functions to actually export them. So we can export a CSV to JSON, CSV to Excel, CSV to dictionary, whatever. So in this case, I'm just exporting this to a JSON file. So when I run this one, we can see should create a new file .json. So I can use this exact file. If you want to see this one, that's what the JSON file looks like. Let's go ahead and load the JSON file into the data frame. So I'm calling it df underscore JSON, and when I do this one, it's exactly similar to what it was before. The only difference is like I've loaded from CSV file before, now I'm loading it from JSON. Similarly, I can also export this to an Excel file. So if I do df.to Excel, so if you happen to run this exact same code, you might have to install a PyXL Python using pip install. That is something you can work out yourself if you get any error. And that's the Excel file which created. Now I'm going to load this file using df pd.read Excel. So when I do that, it did that. It loaded the file, but it actually created an unnamed column, which is basically the index. Here we have index. That's what it loaded here. That's okay. That's not a problem. That's how you read. And there is one more option where you can import the data from the dictionary itself. So you create a dictionary like this. So I have column 1, column 2, and these are the actual rows. So by how we can import is pandas provide a function called data frame dot from dictionary, and that's how it loads the data. So column 1, column 2, these are my two columns. And like I said, this is the data that goes into column 1, and this is the data that goes into column 2. And this also provides another parameter called orient index. So when I say orient index, it basically oriented the matrix. It basically transformed that. So previously what was became rows, now rows now became columns here. I mean, it flipped, it transposed the matrix basically. And we can also specify the column names. In this case, the column names are just 0, 1, 2, 3. But if we want a specific column names, we can specify the columns, column 1, column 2, and the same thing has happened here. And I have one more data set, which is sonar data. I'll just show you this data set. This data set does not have any headers. So that's the reason it took the first data point and made it as a header, but that's not what I want to happen. This is actually a data point, not the header. So when we don't have headers like that, so I want to df underscore csv. See, the first data point has actually become a header. So when you don't have headers like this accepts another argument called headers, and we can specify none. So what it will do is it will use some numbers as indexes as column names, and then the first data point will be a data point, not a header anymore. That's how we do it. And then let's go back to visualize data. Now that the data is loaded into this pandas data frame, how can we visualize? So there is a function called df.head, which will show the top 5 records from the top. And if you want to see more records, maybe 10 records, you can pass a parameter df.head of 10. So it will show you the first 10 records. If you want to pass in a negative value, we can do that by passing a negative value. What this one does is it returns everything except the last 3 records. So my original data set has 10,000 records. Because I said -3, it ignored the last 3. If I do -30, then it will ignore the last 30 records. Now I'm only seeing 9,970 records instead of 10,000. That's the purpose of this head. And df.tail. So what tail does is it will show the 5 records. By default, it shows the 5 records from the bottom of the data set. If we want to see more from the bottom, again, we can pass in the number of data points we want to see. And iloc. This is an important function in pandas as well. Iloc is called index location. So when I say iloc of 3, it will show me the third record. So in the head one, our third record is Audi Q5 2023. It shows the third record. That is, so it is basically getting the uh, third record. And then if we want multiple rows by indexes, so we can specify 2 comma 4. Here, if you see, this 2 is inclusive. It is also Mercedes, Audi, and Volkswagen. So 2 is Mercedes, 4 is Volkswagen. As we can see here, 2 is inclusive, but 4 is not inclusive. The Volkswagen is not shown here. And this can also accept another parameter. So the first one is for the rows, and the second one is for the columns. So if I do this one, what I'm asking my data frame is show me the second and third record, but only the columns from 4 to 7. So we say 0, 1, 2, 3, and then this is the fourth one, 4, 5, 6. And again, those 7 is not inclusive. That's how we can filter out some of the rows and columns from the data frame. And we can also pass in -1. This will give me the last column, which is the price column only. And iloc, if I say iloc just this colon and 2 comma 4, then I'm asking the data frame to show all the rows but only the columns 2 and 4. So it will show 10,000 rows but only 2 columns. That is the purpose of this iloc one. And there is another function called df.loc. It will locate the fourth record. So what is the difference between this? If I add one more cell up here and then print just the df.head. So here the fourth record is Volkswagen Golf 2003 2.6 liter. That's the exact one which is showing here. So what is the difference between LOC and iloc? Loc and iloc. The basic difference between these two is loc is doing it by the key, the index key, whereas this iloc is doing it by the index key. Loc is doing it by the key itself. So to better understand this one, let me give you a simple example. So imagine this Kia has an index of 2 and this Mercedes has an index of 0. So when I do df dot log of 0, I will get this one. Although this is here, I will get this one. But if I do df dot ilog, I'm saying give me the record 0 record with the index 0. So the index 0 is here. Although the key is 2, the index is 0 here. So 0, 1, 2, 3. That's the difference between log and ilog. So this could be a question you might face frequently in your interviews. So it's important to understand that. And then let's jump onto the statistics. So df.describe will give you the descriptive statistics. Like I said here, it is only applicable for numerical fields. So what df.describe will give you is the count of rows, and then the mean for each of those rows, the standard deviation, minimum value, what is the minimum value, what is 25% of your data contains, what is 50% of your data, 75%, and maximum value. As we see, although we have so many columns in there, it only returned a few of them. That's because this describe is only applicable for numerical fields. If there are any categorical fields or strings, then they won't appear here. And then if you want this particular statistics for a single column, then you can do it like this. So df of the column name dot mean. Mean is also called as average. Std will give you standard deviation and so on. Quantile of 0.25. This is also called as q1, mostly used in your interquartile ranges. So that is q1. So when I print all this one, this is one I got. So I've printed this for mileage. Mileage average is 149,000, which matches this one. So similarly, if we compare, all these values will match with that. So this is how we get statistics for a single column. And then df.info. When we do df.info, it will give you the information about the data frame. So what column, the column name, how many non-null fields are there, and its type as well. So this is a non-null count. Everything has a data, so it is all showing 10,000 non-null. For example, if some of the data points have null values, then it will show those count here. It will reduce the count showing it non-null. And then it will also give you the data type, object, intent, and so on. And this one basically gives you a summary. So you have one float column, 5 integer columns, and 4 object columns, and it uses this kind of memory here. And if you see this df itself is a type pandas data frame. And there is another method, df.shape. So shape will give you the shape of your data frame. So in my case, it has 10,000 rows and 10 columns. And observe there are no parentheses here because this is a property, not a method. And filtering, we can filter the data set by some of the strings by specifying the conditions. So I'm using this df filter, df brand is equal to audio. So what I'm basically asking the pandas here is, show me all the rows that has brand Audi. When I run this one, we will only get Audi, and there are 138 rows with Audi. If you want to specify multiple conditions, we can do that. So df.brand is equal to Audi and brand is equal to Mercedes. When I run this one, it will show me the records that has Audi, brand Audi, and Mercedes as well. And this can also be used for contains for the like operator. So if I run this one, if the brand is AUD, then it returns that. But if I do Merc, then it will return all the Mercedes ones. So like operator also works for this one. This one for numerical fields, you can use the usual operators, greater than, less than, is equal to, and all the sort of stuff. So here I'm asking pandas to show me that has mileage more than 290,000, and this is what I got. I got just 300 records with mileage more than 290,000. And if you happen to coming from a SQL background and more comfortable with the SQL queries, then DataFrame also provides a function called query, where you can write more like an SQL. So you can specify multiple columns here. So brand is equal to Audi, dose is greater than 4, and mileage is greater than 70,000. When I run this, it will show the matching rows. I got 179 rows. And then the most important thing of all is data cleaning. So when we get data from different sources, the data is not cleansed. So you have so many unuseful columns, some null values, the values are missing for some of them. that we can do this here. So in the first line, what I'm doing here is locate these rows from 9,953 to 9999, and for the brand and those columns, make those values as none. And I'm doing the same thing for here as well. So for the first two rows, do this. So if I run this one, I would say, because I've cleared the data for 49 rows, it is showing brand 47. So I'm checking is na.sum. Are there any null values? Are there any na values? Then this is what it is showing. Like we saw here for field type, I cleared two of them. Then that's what I got here. And for those, I got 47 rows cleared. That's what I got here. And again for transmission, I removed 5 rows. I mean, I cleared the data for 5 rows, not removed the rows, cleared the data. So that's what it is showing here. So when you have null values like this one, we might want to fill the data or drop the data. One of the easiest one, but not the most recommended one, is dropping NA. So if I do df.drop NA, those records will be deleted. So from the original 10,000 records, now I only got 9,946 because whatever the fields that have null values have been dropped. Okay, this is just a function. I have to reload the data. So I will reload the data here. So I did not run that function. Let me just go back to this and run that function. This one. So again, reload data. I got the original data now. So when we see here, we have so many null values. This drop NA will remove nulls for every single column. But if we want to specify only remove the nulls for brand column, then we can specify the subset. Within the drop NA itself, it accepts a parameter called subset, and we can specify the column name or names. If you have multiple columns, then you can separate it by a comma and then specify all the column names. So if I do this one, so there are no null values. So in order to get the null values, then I have to run this cell again, and then when I do this one, then 47 records have been deleted. And I will reload the data again, the original data, which is done. And another option is fill NA. You want to fill the null values. So this is not the ideal way to fill the null values, but I'm just using this unknown as an example to show how we can fill null values. So when I filled the brands that have with null values to unknown, I did that from the end. Did I run the cell? I think I did. Okay, so we got null values, and I want to fill in a with unknown. Now we say the null values have been, wherever there is a null value, they have been replaced with unknown. So that's how we can fill null values, and then we can find duplicate values. So I don't have any duplicates in this one, but if you happen to have any duplicates in this, then you will see those duplicate rows here, and you can decide if you want to drop duplicates. So it will drop a duplicate value. And this also has properties like keep first or keep last, and it will drop the other record. And value counts is an important function where it will show the value count for that particular column. Now I chose brand, so for brand it is showing me for Ford there are 1000 vehicles, for Audi there are 1031 vehicles, for Volkswagen, and so on. These are the value counts. And there is a unique function as well, which will actually give you the unique values for the column. So I took for brand, so these are the unique brands I have. I can change this column to maybe fuel underscore type, for example. Then it will show all the unique values: diesel, hybrid, non-petrol, and electric. So don't worry about this because I cleared some of the data on top. And then column manipulation. So it is really important in for data professionals, like when there are unnecessary columns, you want to get rid of some of them. So we can do that by using df.drop, specify the column name, and then xs1 means drop the column. So if I do this, as we can see, the price column is gone. There is no more price column here. Previously there was price column. Now I deleted the price column using this drop function. And we can also rename the column. So for example, I have this column name field type here. I don't want the field type. I'm more interested in if the vehicle is EV or not. Then I will modify the column name to EV. So when I run this cell and use this df, this time the field type has been changed to is EV. If you want to add a new column, we can just add with this notation df of the column name you want to is equal to, and I'm just copying and creating a new column using the brand itself. So when I do this, I got a new column and the data is exactly the same as the brand because I've specified copy the data from brand. And you can use some mathematics as well. I have the year here, but I don't know the age of the car, which makes it more easy for me to see how old the car is. So I can do 2025, which is the current year, minus the d of year. And so when I run this cell, we can see there is a new column called car age because I specified car age here. And then 2025 minus 2020 is 5, 13, and so on. That's how we can actually do mathematics as well. If you can use subtraction, addition, multiplication, it's up to you what you want to do. And then this ev, the column ev, which I have done. So if it is electric, then I want the ev to be 1, otherwise 0 as expected. So we can do that using what is a function called apply. So when I do apply, there is a lambda function x. So this is an iterator that goes for every single row, and if this row is electric, then put it 1, otherwise do it 0. That's what I've done here. When I run this cell, this time around the ev column has changed from 0 to 1 instead of petrol, diesel, and electric. That's how that works. And then df.info, this is something we have seen previously already. And if you want to get the information for a single column, we can specify the column name and then just do .info. As we see here, the information, the class for the entire data frame is data frame, whereas for this one, this is a series. So the difference between this one is data frame is a two-dimensional array of rows and columns, whereas series is a one-dimensional array, which is just for one column. And indexing is another important one where you want to index. So here we have seen the indexing is done automatically using 0 to 9999. But if I want one of my columns which I think may be unique to be my index, then I can actually set that to index. So in this case, I'm doing df underscore set index, df dot set index to be brand. So I'm using my brand as the index. And let me print this data set. If you see this one, there is no 0, 1, 2, 3 indexing here. Instead, my brand has created into an index that become bold as well. So that's how this indexing works. Now if I want to find all the rows that has the index key, I can do this one. It will return all the records that index key. So instead of using lookup 0 or lookup 1, I can use the label itself to do that. And we can also use sort the index. So it is done using what is called sort underscore index. When I do that one, it will sort the index column alphabetically from A to Z. So we see all the Audis on top and Volkswagen at the bottom. If you want to sort it the other way, not by the ascending order but the descending order, then we can use df.index sort descending, and this time around Volkswagen will come on top, and then other values will go at the bottom. And if you want to clear this index, I have created index, but this time I want to clear the index, then I can use reset index. Now the index is gone, and again it's gone back to the default indexing that Pandas data frame will provide from 0 to 9999. And sorting and grouping, sometimes it is very important to sort or group the data. So we can sort the data of a particular column. Here the Kia, Chevrolet, Mercedes, they are like everywhere. But if I sort this one by brand, then all the Audis will come on top, and the null values have gone at the bottom. So if you remember the loc and iloc, which I said previously, the difference between loc and iloc, now that the data is sorted, right, this Audi has come on top, but this is actually the 4729th row. So this is iloc of 0 is this one, but loc of 4729 is also this one. That's the difference basically. And again we have sorting the rows with ascending or descending order. When I set ascending is equal to false, then I have all the Volkswagens on top. And we can group by columns as well. So if I want to see the mean of mileage after grouping it by brand, model, and transmission, then we do df.group by brand, model, transmission, and then mileage dot mean. This is how we see the data. So Audi A3 automatic transmission, then the average mileage is this one. If it is Audi A3 manual, the average is this one, because I'm grouping by brand, model, and transmission here. Brand, model, and transmission. So that's how the grouping is applied. And after grouping, I am looking at the mileage, the mean mileage. So that's the mean mileage. That's how it works. And it also provides some graphing capabilities as well, the Pandas data frame. So let me just do this df of brand dot value counts. So when you do this one, it is just showing me the value counts. For Ford there are 1045 cars, for Audi there are 1031 cars, and so on. If I want to see this on a bar chart, data frame actually provides plot dot bar as well, so it has a plotting capabilities as well. So when I do that one, it shows this like Ford 1041, which is saying Audi, Volkswagen, and so on. And I can also do a pie chart. So this plotting has like histograms, KDEs, box plots, bar charts, pie charts, violin plots. There are so many things. Although we use less of these charts from Pandas data frame, more from the Matplotlib and Seaborn, Pandas still has the capacity which we can leverage on this one. So that's it for now. These are the most important features. There are like lot more than this one, but these are the ones which we use on a daily basis. So I will try to find some time and create more advanced video on this one, but that's it I have for today. Thanks for watching. Bye.